Okay, sweet. We are live. Okay. We're just gonna pull that up. No. Okay. So I just got finished with, and the reason why I'm a little bit late is I just got finished with learning about, um, I'll just put this guy for here now, um, genetics and biology. So I watched, is it Steven? A podcast today, or listened to it rather. Um, and I've been thinking recently about.
There's
Um, I've been thinking recently about learning. I know, very surprising. Um, and thinking about how I would be. Yeah, how my daily interactions with new material, like when I'm watching this podcast. I've gone through a lot of the episodes here, um, but I'd like to be able to start like more deeply engaging with the material. I've worked with like while I'm listening to it to sort of think through, or if someone is going to begin to propose an idea, or like retort or make an argument, I try to predict what they're going to say, or what the argument will be, as a way of engaging with material. Um, I I also I don't do anything about it, but I do realize when topics are raised that I don't understand. So that could also be an angle for attack, to be able to understand it more deeply. Um, Additionally, I today actually, I just started this thing um, where um, I began to have a conversation with ChatGPT. Unfortunately, the voice can't. It doesn't have the context of the conversation outside of the voice, right? And then it also doesn't can't access the internet, so that's unfortunate. Um, so I sort of had to like type. I had to bring the transcripts over from YouTube and put them into this conversation, and then I sort of got a summary of the more technical topics discussed within the conversation, and then I yeah, after I got the more technical topics discussed, I'd sort of dove into each one of them and sort of recursively asked questions where I did not understand. Um, so, like examples of things that I didn't understand or that I'd forgotten. Um, my understanding of like the 23 chromosome pairs was like, I knew that we had 46 chromosomes, right? And I knew that there were six chromosomes, XX, or sorry, X and Y, right? But I didn't like the picture there wasn't fully fleshed out. As part of this interaction, I was asking about like what's the total amount of chromosomes, or sorry, what's the total amount of gene? I guess they're gene pairs. Is that what they're called? A gene pair. Yeah, yeah, a gene. Oh no. Um. Okay. Gene. Okay. I guess it was an S. Well, okay. Anyway, so because I want exactly what the pair is. Um, S&P is too specific. Anyway, so I just like misunderstood, like I didn't have a correct conception. And the good thing about these questions with large language models is it can root out your misconception. So I knew we had like these 30 or 20 or 23 pairs, and I was interested in knowing about like what the total gene count. Let's see. We're gonna look into this because I'm looking for a word that I can't recall. So we're looking though for the one that has 3 million in it. Okay. Okay, how many base pairs? That's what it's called, base pair. So I like asked the question about like how many total base pairs, and then I also asked the question about the X and Y and chromosomes, and the X and Y chromosomes are like an order of magnitude of our total base pairs. So I was like, wait, that's odd. And then I realized that like obviously like we have 23 pairs, right? And just the sex chromosomes are only like one of those, right? And so that was it was interesting because like I could have probably if I would have been more like if I could have thought through it more, but it was clear that my representation of what was in my mind was incomplete for this particular thing, right? So the conversation was really good, and then I feel like I think I generated like anyway. I was able to generate a few, or I guess many new things that I didn't understand prior. But the sort of interaction between the large language model was really helpful. The voice interaction as well as the text was really helpful for rooting out the things I didn't understand, and also showing me new things that I wasn't exposed to previously. And then, so I'd like to refine this more because there are more things within this podcast that like, obviously like this guy has a physics background. So pretty technical, but there are a few more things within the podcast that like I didn't understand, like, or rather I'd like to understand more. Maybe that's a better way of putting it. So I think next time I listen through one of these, I'll just have like my notes up and then like note down specifically those things I'd like to understand, and then do something like this again, or do something like this, interacting with a large language model for those specific things, because there are a subset of things that I can't recall from this podcast that I'm still wanting to learn, right? So even asking, the large language model, even after I loaded it in the transcript, the summary wasn't sufficient for grabbing everything. So that means I need to be, on top of it and select and grab more things. So I'm excited for that. And I think like Dwarkesh Patel's podcast is just like absolutely fire. And so if I just merely learn the things that are talked about within the podcast, my competency will definitely increase. So it's a dub. It's a dub. Okay. Perfect. So I think we are going to start with Anki. Huge surprise. Okay, and then I also need to where is topics? Okay. We'll just pull this up. Oh, there was one thing that I thought or that I interacted with someone recently. It helped me refine my ideas regarding Anki and like the use of Anki and other like space repetition tools. In that Anki is a powerful tool, and we should use it to memorize our understanding, we should use it to memorize our understanding, and not as a, like, instead of using it as a learning tool, we use it as a remembering tool. Because one of the negatives, or I guess not negative, but this is an actual reality with Anki, is that it is cued recall. We receive a question and we are supposed to bring recall to our minds an answer. And that is an atomic relationship. And you can have the reverse cards. And then additionally, you can have cards that like link ideas. So like how is this idea and this idea different? And that can sort of break the typical atomic nature of an Anki card, which is helpful. Additionally, if you were to learn a new topic and just merely have the Anki cards, you would be not well served, because you'd have the Anki cards in their atomic nature, but you wouldn't have the greater context of how everything interacts together, or at least not well. And that can be addressed quite easily just by like listening to a lecture or listening to a YouTube video that shares all the concepts within their context with each other. So if you just merely like get transcripts, make Anki cards and load them into Anki and learn that way, you are going to be spending more time reviewing cards, because if you were to engage with the material initially and interact with it such that you're using high order learning, so you're ensuring that you understand particular things, and if you don't understand them, attempting to increase cognitive load and make it like, more difficult, or use approaches to deeply understand them in the moment, then like, yes, you spend that additional time here, but the benefit of it is that you don't have to spend that time later, that the Anki card can merely become a check whether or not you remember this thing. And then additionally, when you learn it here, or rather, if you try to learn it in the Anki cards, you will always have a less good understanding than if you were to like work with an idea, determine if you understand it. Another thing I realized is that we all, like many people, or I guess some people, have difficulty with determining whether or not they know something. I don't think the determine if you understand it. We have that or most people don't have that mechanism understood, or they can't recognize it very well. And I think as evidence of this, we have the Feynman technique, right? Which describes that if you can teach something, well, I guess there are two portions that are typically talked about with the Feynman technique. One portion is the learning portion, and one portion is the revealing that you understand something portion. The learning portion is like, oh, if you teach something to someone, it'll help you learn it, to remember it more. Okay, yeah, I think that's reasonable. And then you also have the understanding portion, is that if you don't, or if you are unable to teach someone it, that means you do not understand it. So if this is a helpful thing at all, that means people typically don't have the ability to determine whether they understand something. Which is an interesting thought. I hadn't really thought about that much before. Another thing that I thought about this week was about the nature, or rather maybe different tests that could be done to figure out if you understand something. And one of these tests that I thought of recently was to compare this idea with an arbitrarily different idea, or maybe it's a similar idea within the context of the things that you're learning, but it could just be like any other thing, right? So if I wanted to determine if I understood the concept of derivative, I could, compare it with the integrals, right? And if I could compare and contrast these ideas, then that'd be reasonable. Additionally, you could also kind of just pick an arbitrary thing, like, how does a derivative relate, or how does it compare and contrast to a pillow? Like, it may seem odd and be like, oh, obviously there's no similarities there. Well, you could actually like think of some, right? So like you could think of, let's see. So derivative is a greater part of calculus, and which is a sort of it's sort of the rigorous beginnings to much of mathematics and supports other mathematics, right? And so pillows support and calculus supports, right? Or you could also think like pillows have cases which sort of hide the actual pillow and give you like a nicer approach for it. And for derivatives, you have like the power rule, which is like a fairly simple process for finding a derivative, but it's hiding complexity about like how a function or how like a derivative is it hides complexity about how you convert a function to its derivative form, right? So I haven't looked into like the basis or underlying nature of like the derivative. Like I'm sure there is something such that the power rule emerges, right? There is some like proof. That's the best way to say it. There's some proof such that the power rule emerges as something that is usable for finding a derivative, right? Like Newton and Leibniz didn't be like, oh, like they were sleeping one day and woke up and then knew the power rule. Like it emerged from this, like other process, right? And so similar to that, like the pillow cover hides the pillow, and the power rule hides the implementation, or the like actual like proof. That's probably a better way of putting it. Anyway, so when you are comfortable comparing arbitrary things, that means you have enough idea of the particular thing or things that you're comparing such that you can compare them. If you don't have that ability, or if it feels like incredibly uncomfortable to do so, then it's probably the case that you do not understand it. So that's like another thing you could use as a tool. Yeah, I found that like when I'm going through things, I often can recognize that I don't understand them. So I wonder if it's just some like internal mechanism that you build. If you focus on understanding, maybe that's the key. If you focus on understanding, then you develop the tool pretty quickly, or the muscle pretty quickly to identify your lack of understanding. Yeah, I think that's probably it. Okay, we will start. Okay. Oh, I need to bury this one. I don't know this one yet. Okay. Finding the limit of the function. What is the use of the squeeze theorem? So this says that if like function A is less than or equal to function B, and function B is less than or equal to function C, and function A and C limits approach the same thing, that means we also know that function B also approaches the same thing. Oh, what's the use of it? Oh, okay, so if the central one is difficult to evaluate directly, then the two others that share the same. Yeah, okay. Whoops, I didn't read the question, but. Okay, so this is the integral symbol. A conjugate within mathematics is an expression pair, or the opposite. So I can give an example. X minus 1, the conjugate is x plus 1, but I'm not sure what I couldn't give you like a technical the binomial form. Okay, binomial, that's important. Formed by changing the sign between two terms. For example, the conjugate of a plus ba plus b is a minus ba minus b. It's often used to simplify expressions, especially those with square roots, by eliminating radicals when multiplied. Okay, so the binomial. I think I would like to add what that is. What is a binomial in mathematics? This is, the binomial that results, right? So this would be like a, I don't know, trinomial. A polynomial, is that something? Yeah, a polynomial is something. Okay, yeah, that's called a polynomial. So it looks like, okay. So when we do this, then we reduce down, I think this BA term is the one that like removes itself, or is canceled out. Okay, this is good though. This is connecting back to like high school mathematics. I guess it was probably much earlier than high school that I learned about binomials. Okay, perfect. Okay, so it's a conjugate is a form of okay, we'll just go back one more time. Okay, a binomial is an expression, algebraic expression that has exactly two terms. Polynomial is a algebraic expression that has more than two terms, three or more terms, one or more terms. Oh, okay. So polynomial. So all binomials are polynomials. Okay. Oh, okay. Is a conjugate. This is the for a polynomial. It's the opposite form, or it's for a polynomial. It is a form where you replace the subtraction or addition signs with their opposite to allow you to reduce down the polynomial to a binomial. This is the binomial form by changing the sign between two terms. Okay, perfect. I think that's reasonable. Polynomial, got it. Awesome. Okay, so I would like to start streaming more because, like, I really get just maybe less than 20 minutes of maybe on other streams I'd be able to do a little bit, or some streams I do better, but like right now we have like 20 minutes. So I might change that in the future. Okay. Okay, so I think last time we decided that I'm just going to go through the MIT exam, and then if I can solve it, good, or if I can solve the problem, good. Then if not, let's see, I have like 20 minutes. Yeah, I think that's reasonable enough time to do that. It looks like can I no calculators. Okay, so I may use a calculator for this sign portion because I feel like it would be difficult to identify because I'm not terribly familiar with the trigonomic functions. Okay, identify the real numbers at which f of x is discontinuous. Okay, so if x is greater than pi, then we do sine of x. And then if x is less than or equal to pi, then we do x minus pi. So for discontinuities, I could graph it, and that would give me the resulting or it would show me the resulting discontinuities. Additionally, I know that things are discontinuous when I can input a value at x, and I don't get a y value out, or it becomes undefined. So, and if we're looking at the real numbers, okay, I also should learn a little bit of number theory, because I honestly have no clue what they mean by real numbers. The real numbers at which okay, additionally, yeah, I'm not sure. So it's saying real numbers, so let's see what real numbers are. Could you give me a little introductory number theory? I'd like to know what the difference between rational and irrational numbers are, whole numbers, real numbers, etc. Give the definitions for each of the categories of numbers, and yeah. Okay, so I think I'm going to quickly notate these. Well, maybe I'll save it for later. Yeah, I think we probably should just push through the exam right now. And so I think I will save this for later. Though I do need to know it. These won't be too hard to recall. Okay. Perfect. Let's head back to so when it says real numbers, we're saying all the numbers that exist on the number line. Okay. Identify the real numbers at which f of x is continuous. Is discontinuous. So I think I have to find, so it is, yeah, so I have to find which input, like, just does not work. And I think anything that or all things that are less than pi for this piecewise function, are safe, because I don't think I don't think you can generate something that's discontinuous because this should evaluate nicely every time. But I think we'll have to figure out what the sign can't do, because so when x is greater than pi, because yeah, at what values is sign discontinuous? Continuous everywhere. Oh, well. I have to connect back to my understanding of discontinuous. So my understanding of discontinuous is that for a given input, like the output is not computable. And so I think this is, let's see. I think I may not be understanding discontinuity within functions. I think it is, or let's see. My current understanding is that for a given input, the output is not computable. So the example would be, x squared minus 4, and then that would be over x minus 2, and that would be discontinuous on positive 2. Could you help refine my understanding of discontinuity? Maybe give a strict technical definition such that I could understand it? Break, jump, or hole. Okay, so that's a hole. Break or jump. Okay. Okay. Are these 3 conditions that you have specified laws? Are they known by any particular name? Okay. Perfect. Okay, so for these 3, C has to be defined, so meaning it's not undefined. The limit of x to C exists Okay. So, so as x approaches c, that exists, and then also f of x, or sorry, this here is the same thing as this to c. Okay. Okay. Yeah, that's reasonable. Okay. So now let us apply. Okay, so if it's discontinuous, okay, so given my understanding so far, okay, I don't think, let's see if I can work through this. Trying to find the real numbers at which f of x is discontinuous. I think I'll just pull this out. Oops. Snipping tool. Okay. So I could work more to like get the resolution here, and I would understand it more. And I think, given what, well, let's apply just a little bit. We'll see where it takes us. Okay, so, yeah, I think in my mind I'm really stuck on the fact that, oh, okay. I understand now. Okay, so, but, okay, that was actually a really powerful thing that just occurred. Okay, so, I was able to identify where I was stuck for this thing. So, I just received the definition of the, like, what a limit is defined as, right? And I think I might have said this just a few moments ago, but I was saying that this is what I thought of as a as like what the only thing a discontinuity is that is when a particular input is not defined in the function. But that is not the case, because we also have, like, if we're approaching, okay, so this, as we approach C, that has to exist, right? And then also f of C also has to equal f of C also has to equal our function as we approach C. So as we get infinitely close to C but don't actually hit C. And the reason why that's an issue is that if we go back to our function in the paper or in the exam, as we approach as we approach pi here, we'll say our limit is pi. As we approach pi, we are going to be using this function here. Let's see. So if x is greater than pi. Okay, so maybe the transition occurs as x is more than pi, right? So I don't think I guess the discontinuity is on pi, but it is as like going from a large number to pi is where the discontinuity occurs. So it's a right-handed, or yeah, I guess it's right-handed because for this one here, so if we were to go from 0 to pi, there would be no change. It's only as we get slightly more than pi that we that becomes an issue. So yeah, that's my approach here. I'm gonna give that a check. So I would say that it is merely pi, but the issue I have is that it doesn't feel like I'm being yeah, so the issue I am having right now is Excalibur. Let's pull that up. Okay. So as we approach pi, from like positive infinity, we'll say, as we approach pi, it's only once we cross in like we're at pi that like the discontinuity occurs right here just before we hit pi. And so I feel like it's not correct to say pi because it's like to the left of it. But we'll see to the left of the actual discontinuity, right? But yeah, I'm not sure. We shall see. Bum ba dum bum bum. Okay, yes, it's defined. Condition 1 is satisfied. Does the limit wait a second. Okay, it's saying that it is continuous for all real numbers. But the question makes it sound like that is certainly not the right answer. Let's see if we get the reasoning model. Okay. So I do want to I do need to write down that I need to be able to do continuity checks. Okay, perfect. I think we will end there. Yeah, I think we'll end there tonight. And then we'll start tomorrow at the same spot. This has been good. I think I, in retrospect, I think I was a little afraid of the more practical, and so I just opted for like a conceptual focus, which was good. Though I think having the conceptual and then also interacting with the practical hand in hand would have probably been helpful, or like get a decent conceptual and then dive into the practical. I guess that's what I did here, but yeah, I'm just thinking now, like, because I knew what continuity was, but checking for continuity, like I said earlier, I could like look at it on a graph and probably could tell you if something's just if it's discontinuous, but yeah, and I'm not sure about this answer because the question really makes it seem like that is incorrect, right? They lead you to believe that there is a discontinuity. So, yeah. Okay. So it was good that I was able to identify that that pi was important because being that it's a piecewise function, that's when we'd have something go on. So that was good. Perfect.